Hello, Year 10. Welcome to week 155 of lockdown. Obviously not, but you are going to do a physics project on waves and the electromagnetic spectrum this week. Now, usually Mrs. Robson would set the physics work, but because this is really just some recall work, it is okay for any of your teachers to do it. Plus, we all know about this and we can all help you. Now, the first thing you're going to do is you're going to recall the structure of the waves and have a look at the different types so that you get a little bit of information before you move on to the electromagnetic spectrum, which in my opinion is the most exciting part. Now, this lesson you are going to do a series of tasks that just kind of jog your memory. You might need to use your revision guides, you might want to have a look on YouTube, but you should be able to answer these questions. It is recall, you have done it before with Mrs. Robson, or you've done it in the previous years, so you should be able to have a good understanding of these things I'm talking about. Now, the first thing you're going to do is you're going to try and do this cryptogram. This is the most difficult cryptogram I've ever given a class ever, so maybe spend about 5 to 10 minutes trying to work it out, and if you can't, then that is fine, but if you can, that would be great, and please let me know what the answer is, because I will send you a postcard for that, as it is difficult. It was difficult last year when I was teaching it in lesson, so it's definitely going to be difficult now. Now, the next part is what are waves. So before we move on to getting you to do anything, we've put some information together. So the different types of waves. Usually in the class I have people doing a Mexican wave around the classroom when I ask them to demonstrate it, so which would be an example of a wave, to be fair. But there are some examples in real life. So sound waves, water waves, seismic waves, light waves, and electromagnetic spectrum. Not that Mexican waves are imaginary, which is what I just implied. But you get what I mean. So, two different types of waves. They transfer energy, so it's all about energy, so it's very much based in physics. They're mechanical and they're electromagnetic. So just have a read about those two different types. We are not moving on the electromagnetic spectrum this lesson. We are focusing on mechanical waves, but just to remind you that it's a different type of wave in comparison to sound waves, water waves, seismic waves, and those kind of things. Now, there's a nice video on wave motion. It's a recap. You might want to watch that video just before you go on to the next part, just to make sure that you're prepared for the activities at the end. Now, after that, you have some questions. So these are some questions that we want you to answer from this video. In class, it will be something that will be taught directly to you. It's exactly how it will be taught. You might, because we would use the Slinky, and you'll see what I mean by that when you watch the video. Now, there is a nice slide showing you the motion of the two different waves. Kind of watch one particle, you can kind of see what happens to it. And you do get a little bit mesmerised by that, so don't spend 10 minutes just staring at the slide like I probably would do. Now, after you've done that, you're going to match the definition to the keyword. And like I've said, you should have watched the two videos, you should have a good understanding from previous years, you should be able to do that pretty quickly. Now, once you've done that, you're going to label the key parts. It says use the key words, but I haven't put them in because I feel like you've got enough information beforehand to be able to label those waves. Now, after that, you've got the wave equation. So this first slide just tells you about the wave equation. So you've got wave speed equals frequency times wavelength. And I've put the triangle on there, which I'm not a big fan of these triangles, but it's on there if you need to use it that way. Now, we are familiar with speed and length, so what do we mean by frequency? And it's just because frequency is a strange word to have to think about. You might know what the word frequent means, so you might understand that it means if something happens frequently, it happens again and again. So it's how often something occurs. And in physics, it refers to how many cycles occur per second. So when we get on to the next lesson, you'll see that a little bit easier. For this lesson, you just really have to understand what is happening with the waves. Now, that is for reference. It's not, you don't have to do anything on this slide. It is just there because it will help you with the worksheet you're going to do when you come to do these. Now, the worksheet is already on the PowerPoint. You don't have to click on anything or go anywhere. I've put it straight on the PowerPoint to save time because usually people can't get access to it or something like that. So this saves a lot of time. Now, question 1, sound wave is a mechanical wave, not an electromagnetic wave. This means that, so you have to read these and answer that question. So what does it mean? Question 2 is there as well, so the questions in bold, the answers are A, B, C or D. Pick one. It's up to you how you do it. You might want to just write it in a box, you might want to highlight it, you might want to, I don't know, any way you want to do that, put a box around it if you insert a shape, however you want to answer that question. Now the next part is some questions. Now you might have to think outside the box with some of these because they're not specific examples given in the PowerPoint, and that's what I want you to start doing. I want you to start thinking about these things in real life and in different situations, because that's what's going to happen in GCSE. So the sonar device on a fishing boat uses underwater sound to locate fish. Would you expect sonar to be a longitudinal or transverse wave? So how would it travel through water? Would you expect it to be that kind of motion where it's up and down, or that kind of motion where it pushes and pulls? You have to think about that. Now, the next question, describe an excellent wave. Look, waves like transverse waves, so they're not imaginary because they're on your question sheet. Then describe how a line of people would have to move to produce a longitudinal wave. I've done this in class. So think about if you were with your mates. I'm thinking particularly about set one. You'd be quite funny doing this. If you were with your mates, what would you have to do to them to demonstrate a longitudinal wave? Now, sound waves travel through air at a speed, and these are your questions that are going to use that wave equation. So really, the only big piece of work you have to do this lesson is this property worksheet at the end. Everything else is simply just little bits of information that should really already be embedded in your mind. And if it's not, then you should be doing a little bit of reading using your revision guide and things. And you should be answering those questions in your revision guide. I have the answers. If you need the answers to something you've done in there, just email me. I'll take a photo of it and I'll send it to you because I have a booklet. Or bring it in when we get back. We can have maybe a session during one of your period 7s or something when we go through a section of your revision guide. So any questions, please email any of your teachers. I would email me or Mrs. Lister because Mrs. Robson, as some of you will know, is in school at the moment doing the year 10 sessions. If you are in one of those sessions today, please let me know if you haven't been able to complete all the work, and I'll have to work out what to do about that. So good luck. Bye.